Hi, it's Mr. Bennett, and in this video we're going to talk some more about the factors in an area that affect what living things can grow there. In our last unit we talked a lot about carbon, phosphorus, nitrate, and so forth, which are all very important things and things that life need to have. But as important as they are, they're not the most important thing that affects what living things can live in an area. The most important factor that can affect what organisms can live in an area, there's two of them. There's two factors that are more important than anything else in determining what can live in an area. Those factors are what's the average temperature and what's the average precipitation. These two factors have more of an effect on what living things can live in an area than anything else. These are the two most important factors. Let me give you some examples. Here we're looking at four different ecosystems. Here we got the Amazon rainforest, here we've got the Atacama Desert in Chile, here we've got the Yukon in Alaska, and here we have Antarctica. Well, all of these things have some similarities. First off, these two ecosystems, the Amazon and the Atacama Desert, they have the same temperature. They have the same temperature. Both of them get up to about 110, 115 degrees, but obviously the difference is going to be you have a whole lot more precipitation in one than you do in the other. So that is where one of these important factors comes into play. Same thing over here. Antarctica and Alaska have roughly the same temperature. The Yukon and Alaska gets down to -70. Antarctica gets down to about -70. Why do we have trees here? Because Alaska gets a lot more precipitation than Antarctica does. Antarctica is actually the driest continent on the planet. It is drier in Antarctica than it is any other continent on the planet. So here you can see the effects of precipitation. Now let's look at temperature. Let's look at the effects of temperature. The Yukon area, parts of the Yukon and Alaska get almost as much rain as a rainforest, but obviously they're different because obviously they have different temperatures. Same thing here. The Atacama Desert in Chile and Antarctica, they get roughly the same amount of precipitation, less than ½ an inch a year, but obviously they're considerably different based on the temperature. So the average temperature of the area and how much precipitation lives in an area, it happens in an area, this will have more effect on what living things can live in a place than any other factor. So if we're going to talk about average temperature and average precipitation in an area, we need to talk about climate. Well, a common misconception is that people get the idea of climate and the idea of weather mixed up. Let me explain what they are. Weather is talking about what the temperature and precipitation are doing right now at this instant. No more than one day out from now, what's the weather and the precipitation going to be. So if you're looking at it and you say it's 45 degrees outside right now, that's what we're talking about, weather. Now weather is very important, but weather is only looking at a small little piece. And climate, when we're talking about what living things can live in an area, the weather doesn't matter so much as the climate. Let me explain this for you. This little dot right here, this is Yankton, South Dakota. Yes, funny name, I can hear you laughing now. Yankton, South Dakota. I actually lived here for a little while. Now, when I first moved to Yankton, it was 115 degrees. 115 degrees. Extremely hot. Rainforest hot. Hot enough to grow palm trees or whatever else you want to do. So really, really hot. That was the weather in August. It was 115 degrees. 4 months later, in December, it was 44 below zero. So in August, you would think, hey, it's warm enough I can plant a palm tree. In December, you know you can't plant a palm tree because it's 44 frickin' degrees below zero. That's an example about climate, that when we talk about what living things live in an area, the weather really doesn't matter. That's just the day-to-day stuff. We got to look at the climate and ask ourselves, can something live in this area for a while? Another example of that, you go over to Brigham City. They have lots of peach trees over there. In Cache Valley, we don't really grow peach trees. Why? It's too cold here. Just the little bit difference in the climate between Logan and Brigham City is enough to make it so they can grow peach trees over there. We can't do it as well here. So what is the climate? Climate is the expected weather in an area for a whole year. That we go back and we look at what was the temperature for every day of the year for a whole year, and we average that out. And that gives us an idea of what the climate is. Here, this graph up here, this is the climate graph for Logan, Utah. Now, this is what's called a climate graph or a climatogram, and it shows you two things at the same time. The bars are showing you how much precipitation you get. And you can see the precipitation over here, 1 inch, 2 inch, 3 inch. The lines are showing you the average temperature. So you can look at this and you can see that the average temperature in Logan in July is just under 90 degrees. You can see that the average temperature in January is just above 30 degrees. Now that's the high temperature. The blue is obviously the low temperature. The bars show you what the average precipitation is, and you can see based on looking at this graph that the climate in Cache Valley means that we get most of our precipitation in May, not so much in June and August. So this is an example of climate. That what can we expect the temperatures to be in an area in a given year. This is an example of weather. What's the weather at 9:45 p.m.? Well, it's 46 degrees, 91% humidity. This is weather. Predictions of what the weather is going to be year after year. That is climate. And we care about climate when we're talking about living things more than we do about weather, because living things have to be able to live in that area for the whole year. So even though there might be times of the years where it's definitely warm enough we could grow palm trees here in Cache Valley, there are other times of the year where it's obviously way too bloody cold to grow a palm tree here. So what causes these different climates? There's a couple of smaller things that affect what your climate is, but the big daddy that affects what the climate of an area is going to be is what is the latitude of that area. Now if you don't remember, latitude is how far away you are from the equator, or how far north or south of the equator you are. It goes from 0 degrees to 90 degrees. Here in Cache Valley, we're about 42 degrees. So actually here in Cache Valley, we're actually closer to the equator than we are to the North Pole. So that's what latitude is. And what latitude you are at has a bigger effect on your climate than any other factor. And the reason for that is the Earth spins on an axis. The Earth is tipped 23.5 degrees. Now because the Earth is tipped 23.5 degrees, certain parts of the planet get more direct sunlight than other parts of the planet. Here around the equator, the light from the sun hits the Earth directly, and it hits more directly. Whereas here on the poles, the Earth hits at more of an angle, and when something hits at an angle, it's more likely to bounce off. And so what happens is areas that are close to the equator get more direct sun, so they get more energy. Whereas areas close to the pole, when the light hits that area, it bounces off and more of the energy is lost to space. And this is the reason why the warmest parts of the Earth are right here, and the coldest parts of the Earth are up here towards the tips. Because once you get up here to the poles, more of the sun's energy bounces off and is useless to you. Now, based on this latitude idea, we divide the Earth up into 3 basic areas. Now, there can be minor exceptions in each place. But the area around the equator, between the Tropic of Cancer and the Tropic of Capricorn, this is what we call the tropical zone. And this is where you find all the jungles, all the rainforests on the planet are in this tropical zone. This is the place where it stays warm 365 days out of the year. This is also the place where if you've ever lived close to the equator, the sun comes up every day at 7 o'clock and it goes down every day at 7 o'clock. You don't get like you get here where now it's dark at 5 o'clock. Whereas during the summer, it's still light at 9 o'clock. At the equator, because they're always getting constant sunlight, the length of the day stays the same and it always stays warm. As you move further north or further south from the equator, you move into what we call the temperate zones. And these are the areas that have the 4 seasons: spring, summer, fall, and winter. At the equator, it's pretty much summer every day. They never really have a winter. It's summer every day. But once you get into the temperate zone, that's when you start seeing winter in your 4 seasons. And then, of course, when you get to the poles, this is where it gets really cold. There's times where for 3 months out of the year, you don't even see the sun, and it's the coldest of all. And so all of these different areas have different things that grow in them. And the reason why different things grow there is because they have different climate. And the reason why they have different climate is because each of these areas gets a different amount of energy from the sun. Around the equator, you get lots of energy from the sun. In the temperate zones, you get less, and then at the poles, you get the least of all, and that's why they're the coldest. Now, because the sun heats different parts of the Earth unevenly, that some parts of the Earth get more energy from the sun than others, there's going to be some effects we're going to see from that. Number one effect we see is what's called the prevailing winds. Wind is caused because the sun heated up one part of the Earth more than the other part of the Earth. And what happens is when air heats up, it rises. When air rises in one place, air from another place has to come in and replace it. That's what wind happens. whenever air gets heated up, it rises up, and that causes air from another place to come in. And so what you see going on here is these arrows represent the general direction that the wind generally blows in that area. You see these arrows here all pointing to the equator. Why is wind always blowing to the equator? Because of the equator, the air is getting warmed up. As it warms up, it rises up, goes further into space. And so air is pulled from other parts of the earth to make up for that. And so these are the prevailing winds that it isn't hard and fast, that the wind can obviously blow in any direction, but generally what happens here in North America, the wind blows towards the northeast based on the uneven heating of the earth by the sun. Now the same thing happens in the water, and this is what causes ocean currents, that warm water rises and cool water sinks. That when water gets up to the poles, what happens is it cools down and it actually sinks to the floor of the ocean, and then that water flows along the floor of the ocean until it gets to the equator, where it warms up and comes back up to the surface again. And this is what causes our ocean currents, is uneven heating of the water based on how much energy from the sun is getting there. The ocean around the equator is getting heated up really quickly, and so that's causing a bunch of water to rise up to the surface here, whereas water up by the poles is cooling down very quickly and causing it to sink, and this causes currents. And currents are basically like a river that runs into the ocean. And these can have major effects on climate. Like for instance, San Diego, paradise. If you've never been there, you need to go. It's awesome. You go there in winter, it's barely 80 degrees. Why is it 80 degrees? Because there's this cold ocean current coming from the poles coming down that cools down the water outside of California, which cools down the temperatures. So currents have a major effect on the climate going on in an area. Now I told you that the latitude has the biggest effect on an area's climates, but there's two other things we need to talk about real quick that can have an effect on the climate of an area. Now these are minor effects. These are not nearly as big as latitude, but you can see their effects. First one we need to talk about is we need to talk about elevation. Obviously, the higher up you are, the colder you are. Anyone who's gone to the mountains, anyone who's gone to Tony's Grove in July, it's going to be 90 degrees down here. You go up to Tony's Grove in July and it's 70 because it's at a higher elevation. Let me give you another example of that. Cedar City, Utah. Cedar City, Utah here. St. George, Utah here. Okay? They're 50 miles apart. Huge difference in climates. Check out these climate graphs for both of them. St. George, you can see in July, the average temperature is over 100 degrees. Whereas Cedar City, the average temperature in July isn't even 90 degrees. And so the average temperature in St. George and Cedar City, there's an 11-degree difference between the two. Look at it in the winter. In the winter, in December, the average high temperature in St. George is above 50 degrees. In Cedar City, it's 10 degrees cooler. It's 40 degrees. I've got a niece who's going to college in Cedar City, and she talks about how in January you can go golfing. In Cedar City, you just drive down to St. George, and it's 50 degrees, and you go golfing. Now, what's the difference between the two? Elevation. Cedar City is at 5,800 feet of elevation. St. George is at 2,800 feet of elevation. There's 3,000 feet difference in elevation. And that's the reason why Cedar City is cooler than St. George, is because it's a much higher elevation. So the elevation of an area has a major effect on its climate. Even in this area, it's colder over at Bear Lake than it is in Cache Valley because the elevation in Bear Lake is about 1,000 feet higher. And so that makes the winters colder, makes the summers shorter, all based on the elevation. Another big factor that can affect the climate of an area is how close you are to the ocean. Usually the closer you are to the ocean, the cooler you are. Let me give you an example. Here's Portland, Oregon. Here's a city called Seaside, Oregon, right on the Oregon coast, right on the ocean. Awesome place to visit. I love going to Seaside. Check out the climate between the two. Okay? Look at the climate in Portland around August. Okay? The climate in Portland around August is about 80 degrees. If you check it out at Seaside, the average temperature in Seaside is about 70 degrees. Now, these two places are within 100 feet of elevation. Portland's about 150 feet elevation, Seaside's at sea level. And they're only about 50 miles apart, but there's a 10-degree difference between the two because Seaside's right on the ocean. The temperature, you can see if you look at this graph, it really doesn't change much when you're at Seaside. You're between 50 and 70, pretty much. Whereas at Portland, it can go from 40 to almost 90. And so the difference between the two is Seaside is right next to the ocean, which is going to make it cooler. Portland is inland about 60 to 100 miles, which is going to make it a little bit warmer. So these are two other factors that can have an effect on what the climate of an area is going to be. What's the elevation and how close are you to the ocean?